So we are going to talk about inscribed angles.
Is this hard?
Well, we'll find out, won't we? And already I see a typo, so I'm going to go fix it. There we go, spelled correctly. Inscribed angles. So we have the inscribed angle theorem. You guys should have these notes. You got them before. So if an angle is inscribed in a circle, recall the word inscribed means its vertex is on the circle. Then the measure of the angle equals 1/2 the measure of its intercepted arc. Or you could think of this the other way around. The measure of its intercepted arc is twice the measure of the inscribed angle. Well, it's all important information. For example, if I tell you angle DEF is 50 degrees, what does the arc measure from D to F have to be? 100.
Oops, I divided.
Okay? So the arc measure is twice as large as the inscribed angle. Or the inscribed angle is half of the arc measure. Okay? Next theorem. If two inscribed angles of a circle intercept the congruent arcs, or the same arc, the angles are congruent, which should make sense. So if you have two inscribed angles in a circle intercepting congruent arcs, or the same arc, the angles are congruent. Should make sense. So for example, if we just add a little something onto this diagram, if I go over here and make this point H, notice that both these angles are intersecting the same arc, DF. So what would angle H have to be?
50.
Would also have to be 50 degrees. Okay, they're intercepting the same exact arc, so the angles are also congruent to one another. Theorem 10.7, we're going to have to draw a circle out for this. If an inscribed angle intersects a semicircle, so what's a semicircle? Half a circle. So there's my semicircle. So we have an inscribed angle intersecting that. The angle is a right angle. Why does that make sense? What would be the measurement of that semicircle? 180. So then the angle would have to be half of that. Well, what's half of 180? 90. So that ends up being a right angle. Okay? Which then gives us a right triangle inside of the circle. So there are probably going to be questions that involve you solving that right triangle. And then the last theorem, I need to draw a little diagram out for this as well. If a quadrilateral is inscribed in a circle, so how many sides is a quadrilateral? 4. So there's my quadrilateral I inscribed. The opposite angles are supplementary. So what does that mean for supplementary? Equals 180. So what would be the opposite angles here? AC would be opposite of each other. And then BD. So you would have angle A plus angle C would be 180. And angle B plus angle D would be 180. Okay. So if you have a quadrilateral, their opposite angles are supplementary, so they add up to be 180 degrees. All right, so we're going to use this information and apply it to some diagrams. and try to find whatever it's asking us to find. First example, we're going to use this diagram in circle P. The measure of arc SV is 120 degrees. The measure of angle RPS is 76. Find each of the following. Measure of angle VRS, measure of arc RSB, measure of arc RT, and measure of angle RVT. So we want to probably start off by labeling what we know. So here we know from S to V, that is 120. Okay, and then RPS is 76 degrees. Now, RPS, what type of angle is RPS? Is it inscribed or is it central? This is a central angle. That's what we learned about last week. What do we know about central angles and their arcs? They're the same. So if that's 76 degrees, what's the measure of arc R to S? 76. Okay? So we probably want to take care of that right away. So now let's take a look at what we're looking for. So the first one, we want to find the measure of angle VRS. So VRS. So VRS. Is that inscribed or is that a central angle? That's inscribed. So we want to look to see what arc it intersects. So what's the arc measure that corresponds with VRS? Yep, VS is 120 here. So then what would be the measurement of that angle? 60 degrees. It'd be half of it. Okay, next one asks for arc RSV. So RSV, yeah, we would take 76, and then we'd have to add it on to 120. So 196 degrees.
The next one is 120. RT.
RT, and why are you saying that RT is 120? Good. RT and SV, those are congruent chords. And recall from last week, we learned that if we have congruent chords, their arcs are also congruent. So that means from R to T should also be 120. And so then the measure of angle RVT. So RVT, so this angle.
Did you say 196 plus 76?
We would not have to do that. V here, would this be inscribed? Yeah, it's on. So you have to take a look and see what arc that intersects. So what arc does this intersect?
V to R.
From
V to 3.
R to T it intersects here. Intersects from R to T. So since it intersects R to T, we just have to take half of that. So 60. Does that make sense? Okay, a lot of this is being able to look at the diagram and kind of pull the correct pieces out. All right, so let's do the next example then. In circle R, BC is 3, BD is 5. Find the following, angle C and CD. So BC is 3, and BD, so that whole length is 5. So the first thing we want to do is find the measure of angle C. So C, is this a central angle or is it inscribed? It's inscribed because it's on the circle, so we want to do half of the arc it intersects. Yep, so this would be 90 degrees because it's intersecting the semicircle BD. Half of 180 is 90. So the measure of angle C is 90 degrees. Now we want to find CD. Pythagorean theorem to find CD because we now have a right triangle. So
5 squared plus 3 squared.
5 squared equals 3 squared plus b squared. Or what do we just know it is? It should be 4 because it's a 3, 4, 5 triangle. If you don't know that, solve it. that okay? All right, next example. In circle S, arc KL is 80 degrees, arc LM is 100 degrees, arc MN is 60 degrees. Find the missing pieces. So we want to find angles 1 through 6. So we'll start by labeling. So KL is 80, LM is 100, MN is 60. Can we figure out what the other missing arc is? How can we figure that out? Yep, add those all up together and subtract from 360. So 80 plus 100 plus 60, what does that give you? 240. So when we subtract 240 from 360, we get 120 degrees. So arc K to N is 120. So now we want to find angle 1, angle 2, angle 3, angle 4, angle 5, and angle 6. So first off, when you're looking at all those angles, you want to take a look and decide if they are central angles or if they are inscribed.
Isn't angle L, like 2 and 3 doesn't equal to 90?
We don't know that 2 and 3. Oh, yeah, 2 plus 3 should equal 90. You're right, because that goes through the semicircle. But also notice that all of these are inscribed. They're all on the circle. So we can, 6 is still vertex on the circle. So what we can do is we can look at the arcs that they intercept and just take half of it. So angle 1 here. So follow angle 1 out. If you follow angle 1 out, you see it goes to point M and point L. So what's the arc there? 100. So that means angle 1 would have to be what? 50. Okay, so now do the same thing for angle 2. So follow angle 2 out to where it crosses at N and then at K. So what arc measurement is in between those two? 120, so the angle would be 60, good. Follow 3 out, so N to M. So that arc is 60, so angle 3 would be 30. Angle 4, follow angle 4 out. In between K and L, so 80 degrees, so the angle 4 would be 40, good. Angle 5, follow angle 5 out. So angle 5 goes to L and K, which is 80 degrees. So yep, 5 would also be 40 for half of 80. And then do the same for 6. Follow 6 out. M and N, which is 60. So what would angle 6 be? 30. Does that make sense? Okay. All right, then we got one last problem. Excuse me. Quadrilateral EFGH is inscribed in circle N such that the measure of arc FG is 97, the measure of arc GH is 117, the measure of arc EHG is 164. We want to find the 4 angle measures. So what do you think we should do first here? Oh, so you're labeling them all, right? So FG is 97, GH is 117.
What would you do with E?
EHG. So from E to H to G, that whole thing is 164. So how could we just get EH? Yeah, we could do 164 minus 117 to get EH.
50.
It's what? I just didn't hear you. Go ahead, 47. So that's 47. So we want to find the 4 angle measures.
E.
Do you have any ideas for how you could find these? Or do you know any right away? Think about the arc that it intersects. It should intersect So here we know EHG, right? We were given that one. So that's from E to G. Follow E and G down. Do we get an angle?
90.
No, not 90, but we get this angle F, right? So angle F here intersects the arc EHG. And if we know EHG is 164, how could we get angle F? Divide by 2. So to get angle F, we could take 164 and divide it by 2. So what would angle F be? 82 degrees. Now, that theorem told us something about quadrilaterals. What do we know about the opposite angles? They are what? They're going to be supplementary. So if angle F is 182, how could you find angle H? Yep, do 180 minus 82. What would be 180 minus 82? 98, so angle H is 98 degrees. Okay, so now we just need to find angle E and angle G. Okay, so how are we going to find angle E and angle G? Could you come back in a couple minutes? Thank you. So how are we going to find angle E and angle G? Very good. So to find E here, we could look at where E is intersecting. It's intersecting from H, G, F. So you could add your 117 and your 97 to get that whole arc. So 117 plus 97, what does that end up giving us? Good, 214. And so then angle E would be what? Divide this by 2. 214 divided by 2, good, 107. And then the one supplementary to that would be angle G, the opposite one.
107.
Yep, so 180 minus 107 gives you 73. So those would be our 4 angles. Is that okay? Yeah? All right, so your assignment for tomorrow then. Page 549. 8 to 10. 13 to 16. 18 to 25.